you. Actually, now she gave away that I'm not PDP, so I was actually thinking about doing a prank, just play, okay, say I'm PDP, so when my friend Petko, when PDP watches the video, he goes like, hey, man, you impersonated me. Anyways, I know you're all very tired. My jokes are not obviously working. Thank you very much for showing up, even though it's quite late and it's the very last presentation. Although this presentation is, is by PDP usually. I helped him review some of his, a lot of this client-side security research. So hopefully I should be able to, explain most of the findings. So, the idea behind this talk is that, in security, usually a system is made of different components, right? And sometimes if you analyze each of the components individually, you might not find a vulnerability. There might not be a security issue. But sometimes when different components interact with each other, it could lead to a serious problem like command execution. And we will show some real examples. Also, something for me behind this talk, one of the main ideas is that you don't need to, there's no need to target memory corruption bugs like heap overflows to perform command execution. Here we're going to see a lot of examples of vulnerabilities that, they're exploiting parsing bugs, and there's no shellcode being used. But at the end of the day, you're still able to perform command execution. So going back to the previous slide, different people use different terminologies. The term cross-site request forgery or CSRF is now becoming more standardized, but sometimes you find a vulnerability in which you're forging a request, but in reality there's nothing cross-site about it. This one is a very good example. It's been already a while. I think it was a few months ago. PDP found this vulnerability on Gmail, and it's quite cool because basically on Gmail and most webmail softwares, you will have email forwarding features. I mean, Outlook Web Access, Squirrel, Mail, any webmail software. It doesn't even have to be a public site like Gmail. So it turns out that within the forwarding capabilities, you can create forwarding rules, right? So you can say, I want to forward emails that have the word porn to my other email accounts, right? It turns out that this feature, this request, can actually be completely forged. So the proof of concept that we provided, basically what happens is that someone sends you an email, you click on a link in the email, right? So the user visits the page, but what's actually happened is that in the background there's been a new forwarding rule that has been added, and the rule will email all emails. Sorry, I can't repeat the same word twice. It will send all emails containing the word password to the attacker's email. So as you can see, sometimes, this is not command execution, but what's more important, than email, I mean, this is information theft, information security is not about getting root access to a system. It's about protecting or stealing information. And in this case, we show how someone can steal your emails by simply making you click on a link after you log in on Gmail. Also, going back to the same topic, cross-site request forgery attacks. If you're into routers, I mean, I'm not going to discuss this kind of stuff so much because it's a bit beyond the scope of the talk. But if you like playing with devices and you like researching cross-site request forgery vulnerabilities, there's some really interesting things you can do. Traditionally, file uploads, for instance, they're not meant to be forgeable. A lot of people think they cannot be forged, but there are ways to forge it. This is actually, a proper code snippet using Flash. And of course, if you research any home router and you can upload, you can convert this code snippet to work with a different router, you could potentially upload your own firmware, really. And this is, again, it's a form of request forgery, right? Flash is probably one of the best technologies when it comes to request forgery attacks. A lot of request forgery attacks, they don't require you to be fancy, right? So you can forge most of the times not any, but regular or traditional get and post requests without having to use anything like Flash. So you can do using HTML even or JavaScript. So you don't have to go fancy. But sometimes the request that you have to forge is more complex. So you might see there are customized headers that you won't be able to replicate with JavaScript. There are some exceptions to what I'm saying, but just keep it. I'm approaching it from a general point of view. In this case, the request is quite complex. There's a lot of customized headers, yet the Flash plugin still allows you to do that just by using a legitimate function sent to URL. Somebody got back to us a few months ago. They said this has been fixed by by Adobe. We didn't actually even know this is a vulnerability because we're actually using a proper function. So I guess they thought that the function is a bit too flexible, but we never even approached it as a vulnerability. It's really a design problem, Cross-context scripting. This is something that a lot of people don't realize it's possible. So, we're going to discuss some real examples, and you'll see how with a cross-context scripting vulnerability, you can actually run commands on your system. Again, we're not exploiting memory corruption bugs. No disrespect to memory corruption bugs. I think they're great, but some people think it's the only way to run commands, This example is an example of a potential Web 2.0 worm. Actually, I think today or yesterday there's been a report of a new worm on Facebook, which relies on the Google RSS reader. I don't know if you heard of it, but there's supposed to be something going on. So, the whole point is Web 2.0 worms, especially targeting social networking sites, they're going to become more and more popular. At first, when this Code of the Sami worm was released, people were saying, that's not a worm, you're not interacting with the service directly and then propagating. Well, yes, you are propagating. We just have to we have to change the way we think, At the end of the day, you have malicious code, which exploits a vulnerability and has a replication mechanism, or propagation, mechanism, should we say. And this is the kind of situation that the reason why we included the Pounds worm example is because it's a social networking site. For those that are not familiar with it, it supports microblogging. Perhaps you could compare it to Twitter. And this is a very common scenario when you're writing a worm for a social networking site. So say that you find a field where you can inject dangerous characters, right? So you can inject angle brackets. Now with angle brackets, it could potentially lead to JavaScript injection, which is what you want. But you might find that the field is only allowing a very, very limited number of characters, So in this case, the vulnerability existed in a user profile page. So this is what you do, right? If you have a field that's restricting the length, but it's allowing you to put the angle brackets, what you can do is use other fields that are printed after that field, which allows safe characters to be inserted. So there you put everything else, the rest of your payload. And the things that you don't care about, you just enclose it within comments. Let me show you what I actually mean. So if you look at the zero exploit code, right? HTML junk. Before HTML junk, right? We have comments, and we're finally closing them after HTML junk. Basically, what we're trying to do is we insert the beginning of the script in the field that was restricting the length, right, for the user input. Then you're going to have HTML that's provided by the web page, HTML that you don't have control over. But you don't want this HTML to interfere in your exploits. So you just put it around comments, right? So the interpreter, the web browser, will ignore it completely. And then finally, you will have your actual exploit. So if you're into web application penetration testing, or you're into 2.0 worms as a hobby, you like finding potential vulnerabilities that would allow you to write a worm, it's a very common scenario in which you have a field which is unrestricted, character-wise, so that means you can insert dangerous characters, but the length is still restricted. Don't just think, okay, this is not exploitable, There's still going to be other content in the page that you can manipulate, So just use all the other fields that are filtering characters, but it still leads to command execution ultimately. Of course, this is not command execution locally speaking. This is within the context of the domain. So that means that now you could forge requests, from other users. So you could make things such as, adding a new friend, or perhaps changing your password. If the website doesn't ask you to enter the original password, you might be able to change someone else's password. The payload is really up to you, but the propagation vehicle, at the end of the day, it's going to be something like your user profile. And this is just the proof of concept. PDP developed it for Firefox only for demonstration reasons, and we're just inserting a script located on hackers.org. It's always, when you're playing with cursor scripting, you always want to demo that it's possible to insert script from a third-party page, using a snippet like script space source equals something, or a variation. The reason for that is because then you can prove that you can inject any sort of scripting code. Once you can insert scripting code from a third-party page, you're already proving that you could have any length, any sort of code, any amount, any code that you want. So it's almost like the calculator of the buffer overflow exploit worlds. In buffer overflows, people like popping up a calculator. In cross scripting, if you want to prove that it's fully unrestricted and exploitable, you might want to prove that you can insert script from a third-party page. Also, this research is quite interesting. Whether you're a web developer or you're a system administrator or perhaps you're a penetration tester, a lot of the times you will have websites which will allow you to upload different types of files, right? Now, developers know that certain types of files are dangerous, right? Obviously, you don't want people to be able to upload files that will lead to command execution. So you want to disable common server-side programming languages such as, PHP or whatever languages the web server in particular understands. But, at the end of the day, if you're a developer, you're going to be using a library, and most of these libraries, all they do to really check what kind of content there is in a file is checking the headers, So it turns out that if you play with even, very simple cat commands, and you pipe different files into the same one, it's actually possible to have two different types of files. So the web server will think it's a certain type of file, right, which follows the security policy. But then ultimately, further down the line in the file, you have another header, right? And that could be, it could be a jar file, which again could lead to, running scripting code, running code within the context of the domain. So the point is, this is a challenge that in the security industry we have to overcome. It's not enough when it comes to file inspection to check headers. We must come up with ways to fully, read the file. Overall, make sure that there's nothing malicious there. With this vulnerability, the jar vulnerability, this was a cross-domain vulnerability. So you're basically breaking the same origin policy, which means that you could give a malicious URL which points to your own site, and it could contain, Java code in what appears to be a JPEG file. QuickTime, it's probably one of the weakest links of the web user nowadays. We all have QuickTime, QuickTime plugin on Firefox or whatever browser you use. And unfortunately, there's a lot of issues with QuickTime which lead to command execution. Then again, you don't even need to exploit a memory corruption bug. In this case, just by simply tampering the QTNext parameter, it's possible to run commands within what they call the Firefox Chrome. Chrome in the world of Firefox is like a local zone in the Internet Explorer. It's basically the code is being run with full access on your system. And when I say full access, I mean it would be the privileges of your account. So if you're an administrator, the code can run anything with administrator privileges. If you're a restricted user, then it would run within a more restricted context. But here you see cal.exe. Again, it's the usual proof of concept in the world of command execution. So yeah, it did work, and it did open the calculator. So as you can see, by playing with different supported formats and messing with the interpreter, you can fool it to run commands. And the reason why you see the code being printed in so many different lines is because there's a restriction on the length. So simply what you have to do is, once you already know what's the entire code that you want to run, you basically push it in different statements. And this is just, again, another example of a command execution vulnerability, which doesn't rely on anything regarding memory corruption bugs. It's a Firefox extension. Some of you might have heard it. It's called Firebug. It's very useful if you're into development or even security. It's basically a debugger, for your browser. And in this case, again, it was vulnerable to a command execution vulnerability. So this is what's happening nowadays. You go online, you have your browser, and we load our browsers with so much stuff. So many extensions, plugins. If only one of those components are vulnerable, basically your system can be compromised by simply visiting a page. So it's one of those challenges that we have to deal with as users. We all like installing random stuff, but we don't really know how secure it is what we're installing. So I personally like going online with restricted privileges if I'm on a Windows box. So just don't use an account that has administrator privilege. So if you get exploited, you will at least mitigate the consequence, the privilege that the code is able to run as. This vulnerability was very, very, very interesting from my point of view. It shows that sometimes when you find something, you think that it's less serious than it is. I think it was in the full disclosure mailing list. Miroslav, I'm sorry if I mispronounce his name, Miroslav Lusinskic, sorry, I probably mispronounced it. He sent an email to one of the most popular, one of the popular security mailing lists, and he said, "Look, guys, I realized I found something. There's a cross-scripting in the Skype client, right? It turns out that Skype would allow users to share videos. So imagine you're chatting with your girlfriend, right? You say, hey, check out this Daily Motion video, and then Skype would dynamically include the video clip on the window of Skype and a description and title of the video clip, right? So it's quite cool stuff, from a user perspective, because it makes the Skype experience more fun. So this researcher, he noticed that in one of the fields of the Daily Motion video, right? So say that you upload a video, right? One of the fields that you can enter, I don't remember if it was the title or the description, but one of them allowed JavaScript. So this guy said, guys, there's a cross-scripting. Well, actually, this is not being run within the context of Daily Motion. This is not cross-scripting. As Aviv Rav pointed out, it's a local context or cross-context scripting. That means that this is the main idea, right? You find a vulnerability on a website. In theory, the code that you inject there should be logged to that domain. So it should be run within the sandbox of that domain, which means that that code should not have local access to your system. But because Skype is actually using the Internet Explorer engine in local zone, that means that now the JavaScript has full access to your system. So here, if you notice in the code, we're actually using WScript shell. With this ActiveX, you can run any commands, and there's no warning being shown. So how would you exploit this? Of course, it's been fixed now, but how would someone exploit this Skype vulnerability? Well, create a video that says, I don't know, naked Britney Spears, put your malicious JavaScript. People will search for Britney Spears, click on it. If it's being shared on Skype, it's command execution. Or perhaps the attacker is sharing the link directly on Skype. Remember that Skype will, or would back then, dynamically insert the different fields of the video, of the video that's being shared with the other user. So again, command execution, that's why PDP says that, this presentation is about finding serious bugs without even trying, And also, as PDP pointed out, if the attacker is in your same network, right, in the same wireless network, because as many public tools like Karma demonstrate, it's possible to to reply before the legitimate server replies. So the malicious video could also be inserted by someone in your same network. Of course, the assumption is that the attacker is sharing the same wireless as you. But it's another vector that has to be mentioned, when you're evaluating how bad a vulnerability is and what are the different ways someone would exploit it. Command fixation attacks. Okay, so there's a pro argument. There's an argument against this sort of attacks. Some people will claim, well, if you can trick me to double click on a file, then why not just send an executable to the attacker? Now, we are going to discuss a few different configuration files used by Windows Terminal Services, remote desktop, right? And also Citrix. There are several reasons why you might want to perform command injection by sharing a malicious connectivity file. First of all, a lot of these files, they're text-based, and their extensions are not being filtered by mail gateways. So it's much more likely than a file with RDP extension will go through a mail filter as opposed to a file with .exe or BAT extension. So what these vulnerabilities basically, these attacks show is that it's possible to perform command execution after the user has performed a remote connection to a system. In this case, it's using RDP, right? So the idea is, the commands will be executed right after the user logs in. And this is, it's just an example of a possible social engineering email in which someone is sharing an RDP file and asking, take a look, try the file, let me know if RDP is working, because we've been having some technical difficulties. So as you can see, there's some social engineering involved, but these files will definitely most likely go through the corporate mail filters. So everything is going over the web, so including remote desktop technologies. So what's really interesting from right now, now that a lot of people are switching to doing everything online, sharing documents online, if whenever all of us are connecting to our desktops remotely, these vulnerabilities will have quite serious implications, because from our personal experience, anything that's over the web is quite trivially exploitable. HTTP requests can be forged. There's a lot of opportunities for attacks. So it'd be quite interesting to look in the future. 5 years when everyone is logging to the desktop remotely and their workstations have actually become dummy computers. Just like back in the days. When you had the heavy-duty server and then everyone would connect to it with thin clients. Now we're just doing the same thing again. We're putting everything on a server, The only difference is the server, it's on the internet. Anyone can connect to it. And this is the equivalent in the world of Citrix. Now, in the case of Citrix, it really depends on the configuration, but if you're using Citrix Neighborhood and certain configuration is enabled, again, if you open this connectivity file or configuration file, it's possible to run commands after you log in. And what's really important here is that these commands are not now restricted to your local machine. These commands are being run after the user logs in. So if the victim user has remotely connected to the corporate network, the commands that are being run, the malicious code, could probe any service that should not be otherwise visible from the internet, because the assumption is that you have a secure remote connection. So that's just something, it's important to know that this malicious code would be able to probe any system that would be available in the Citrix neighborhood. And this was quite cool. I mean, back when, quite a few months ago, when there was all these issues being discussed about URL handler vulnerabilities, and you have Microsoft blaming the vendors, and the vendors blaming Microsoft. It's the operating system fault. No, it's actually your fault because you're sanitizing that parameter. PDP found quite a cool way to basically, make the Second Life client authenticate to a third-party site. Now the password is sent as a hash, but it's vulnerable to replay attacks. So you have two options. One, you crack the hash. If the password is weak enough, you'll be able to crack it with rainbow tables. Or, who cares? You don't have to crack the password. You can replay it, so you can still log in by forging the request to the server. And remember that there's a lot of trading in the world of virtual communities like Second Life. People sell their accounts for money because there's literally people that do this as a job. So it's quite interesting. Stealing a Second Life account, it could have certain value in the market depending on how much experience that user has gained through his user account. So now it's interesting because there will be alternative ways, new ways for criminals to make money. It's not only about phishing your banking credentials. Now it's also about just stealing anything that can be sold in the market, like a Second Life account. It's got a value. It will be sold. And this is actually, if you look at the HTTP request and you observe you look between the string tag, that's where the actual hash of the password is sent. That's just for you to know, what it will look like on the wire. Now, if we all like researching a lot of different types of vulnerabilities, but if you stay in touch with reality, we still find two common attacks which lead to most users being compromised or money being stolen. One of them is phishing, and the second one is drive-by download attacks. If you want to read more about drive-by download attacks, Wikipedia has an excellent page. And a drive-by download attack is nothing else than tricking the user to open a file. I mean, I have people in my family whose laptops keep getting compromised, and the truth is that some of these guys, they're really good at faking web pages to make it look like it's the actual operating system. So they will show a web page which looks like Windows XP telling you to update your antivirus. So a non-technical user has really no ways to know whether or not it's the desktop that's telling the user to do something or a website. With this unbuilt-in script, you can create a Java applet with a customized field. So the browser will show a warning because the applet has not been signed. It's not properly signed. But there's a lot of companies connecting to their own websites where they're required to run an applet, and the applet has not been signed. So the idea behind this script, if you're doing a penetration test, which combines a bit of social engineering, right? You could use this script to create your customized applet and with your own customized fields. So ideally what you want to do is make it look like the fields actually match the company name that the victim works for, the website name. So it's a little tool that you could use during your penetration test assessment. And this is, that's again, we're running a command. Of course, remember that the user must be tricked to run the applet, but at the end of the day, if the user is tricked, again, we have command execution. This was the more recent QuickTime vulnerability that was published on GNU Citizen. What's cool about it is that it was cross-platform. It would work on any version of XP. And again, if you actually look at the source code, we're playing with different formats that are supported by the QuickTime plugin. Playing with the parameter in order to trick it to run commands, right? However, in this case, it was not so easy to run commands. If you look at the file URL, this points to evil.lnk, right? That's just a shortcut file. But the problem is that the Java virtual machine wouldn't actually understand that. It won't actually run the code that you're pointing to. So if you have the shortcut file, you edit it, and you make it point to an executable, the Java virtual machine will simply not understand this file type. It'll just do nothing with it. However, if you change the file URL to NetBIOS notation, the Java virtual machine will happily allow you to run the jar file, which ultimately leads to command execution because you can run any commands within a jar file. And this is, if you wanted to replicate this, all you do simply is modify a regular shortcut file in order to use NetBIOS notation, which is basically using backslash, backslash, instead of something like HTTP colon or FTP colon. This was also one of the more recent things. It's one of those things, that one could argue, it might be a design problem, not necessarily a bug. It was kind of like, we released it a few days ago, and Aviv Raf gave some very good feedback, because apparently it turns out that Google, different domains within Google, or should I say subdomains, like say maps.google.com, images.google.com, it turns out that you can swap the subdomains, and it will still show the same application. So say that you have Google Images search results, right? You will have images.google.com, right? But you can change it to mail. Google will happily take both. Now, you might be thinking, well, who cares? You can change the subdomain. There's two implications to this. First of all, if you find a cross-domain vulnerability like cross-site scripting on only one of the applications, you'll be able to affect a different application. So say that you find the cross-site scripting in images.google.com, you now might be able to target mail.google.com in order to target Gmail. And it also allows you to gain more trust from the user. In this case, by tampering the images URL of the images result file, you can change the login page. This is a screenshot on the next page. I'll show it now. But from this URL, all you have to know basically is the entire URL was originally Google Images URL, right? So say that you go to Google Images, right? You search for something, the URL will slightly look like that, because the different applications are being shared among different subdomains. You can change the subdomain from images to mail. Remember that what we're trying to do here is do a phishing attack against Gmail. This is the whole point. If you look at all these weird characters, right? This is actually the URL where the image would come from. It's just hex encoding. It's nothing fancy. You can convert any URL to hex encoding using any online tool. There's a lot of tools that can help you with that. So this scrambled URL is actually a web page hosted on googlepages.com, which is really a completely fake login page. Now, it's not the most perfect phishing attack, but it's interesting. There's a few things that make it likely to succeed. Perhaps the screenshot is not really, the resolution is not the best, but what we have is we have a fake login page, right? That's on the bottom of the page. You can see it's under the border. And if you look at the URL, it says mail.google.com. So the idea is that, by using the same domain as Gmail, you gain more trust from the user. Of course, because the login page that you're inserting through the frame on the bottom part of the page is actually completely fake. It's somewhere else. That means that the username and the password will travel somewhere else. Someone could argue it's a vulnerability. Somebody else will say it's just a feature. But the point here is not to get into semantics. It's really to discuss how different features can be abused for malicious purposes. And this still works because it's actually the way Google Images works, and the domain sharing issue is still possible. It's still there. As you can see, I made quite a small presentation. Mainly because it's the end of the day, it's the second day, and I know probably you guys are ready to party, have a few pints, I don't know, whatever it is, so I try to make it as painless as possible. I'm not sure if you have any other questions or energy to ask a question, but don't be scared. I don't expect you to have understood anything of what I said. So you can ask me again, it's not a problem, don't be shy. Or maybe you have some ideas to research. Please, if anyone has a question, just go ahead. I'm sure there's something, if you're into client-side security, maybe you've been researching something, maybe a Firefox extension, I don't know. It must be something you've been playing with. No reaction, no feedback. All right. Well, should I maybe play some music, man? Let's dance.
I have a question for you.
Oh, there's a question. Where's that coming from? Oh, there you are. Sorry. Hi.
So I work on a browser. What can I do to make your life more difficult as an attacker?
To make the life more difficult?
Yes.
As an attacker?
Yes.
Sorry, you're saying how can you make the attacker's life more difficult, right?
What can I do in the next version of my browser to make your life harder?
Well, your life harder, well, first of all, you want to audit the source code as much as possible, right? And also perhaps you want to allow, you want to minimize any sort of compromise. So perhaps, I mean, Google had an interesting approach that we're separating different tabs within different processes, I mean, it's not a holy grail solution, but you can see how Google is trying to, come up with creative implementations that will minimize possible compromise, Perhaps, it's not really feasible, right? Perhaps, but I personally would like to have, say, in the world of Firefox, right? I like to be able to, to know whether or not the extensions are legitimate or they contain malicious code. Unfortunately, when you go to the extensions repository, you're just hoping that the extensions don't contain any malicious codes, In the case of plugins, like QuickTime, it's quite obvious that they need to improve, Apple needs to improve the quality assurance process. I mean, there's really, there will always be a vulnerability somewhere, but you can see how, I mean, QuickTime is getting owned all the time. Everyone is finding vulnerabilities all the time. So something tells you that they're doing something wrong, Maybe they need to hire 10 security researchers fully focused on QuickTime so they can work with the developers, I don't know. Probably I didn't answer your question.
No. I mean, better code quality is always good. But there's no security feature you have that, man, if everybody did this, that would be the end of me.
I like using NoScript as well, but I realize that NoScript is it's for technical users, in my opinion. I mean, some people don't agree with that statement, but I don't picture my mom using NoScript. Adrian, this is not working. What am I doing wrong? Oh, you have to whitelist that domain. But that's not the same domain as the one in the address bar. No, mom, this website is pulling content from like 20 different domains, and that's one of them. You need that for the flash to be displayed. I mean, no, it's not going to work. But for, computer geeks like us, NoScript is really good, I think. I like it personally, but
cool.
It's not a mainstream solution, in my opinion. But that's just my opinion, I mean.
Thanks.
Okay. Is there any other questions? Any free beer you might have with you? Chilled, if possible? No? Wow, everyone is really, really tired at this time of the day. I don't blame you. I slept 1 hour last night. I just arrived today in the morning, and I had to give 2 presentations. Right now, I don't even know where I am. This is like a dream to me right now. I don't even know if this is happening, It's like a hologram. Anyways, well, thank you very much for your time and showing up.
Well, thank you very much, Adrian. Much appreciated. And do let PDP know we miss him. And he's going to buy us a keg of free beer, seeing that he missed